All right, welcome back, everyone. GE101. This is week 4, and a lecture on scheduling and planning, and also a little introduction to your course challenge. So I'm going to make myself a little smaller. I have a screen share going on with a basic PowerPoint. So let's get to it. I'm not going to go in slideshow mode. I'm just going to stay like this. So I hope that's okay. Reminding you that we have our design loop that we want to work with through the project. So when we get the project going, you need to keep this foremost in your mind. And we're going to talk a little deeper about brainstorming, because that'll be kind of your first phase after you do your teamwork and your problem identification. So just keep this loop in mind. We want to be running it often. All right, so planning and scheduling, very big in engineering. We do it all the time on almost every project, unless it's very small. But this project that the challenge that you're going to undertake is, multiple weeks. So planning and scheduling needs to be a part of your project. So think about it up front. A lot of times when we build schedule, we build it from the finish part of the project, because that's when it's got to be done. And we build it backwards towards the front. So you might think about that when you're starting to build schedule. You'll be required to turn a schedule in at some point, and I'll be kind of harping on you to get going on that. Planning is defined as the process of identifying all the activities necessary to complete a project. So this can be kind of part of your early meetings as a team, is to think about, hey, what are all of the identifying activities that we're going to have to do? Like, we're going to have to build this thing, right? That's an activity. We're going to have to design this thing. That's an activity. We're going to have to on and on and on. Those are the activities. So scheduling is determining a sequence in which you're going to do those things. Okay, so putting those activities or tasks into a sequence. All right. So planning, think about beginning that before you start the work. You need a kind of a clear definition of the scope of the project. It's harder than scheduling. Scheduling is just taking the planning activities and putting them on the calendar, right? And saying, hey, got to be done by then. But you have to, in the planning phase, you need to try to acknowledge every little task. The smaller the detail, the better, okay? Break projects into well-defined units of work. That's what you want to do with your planning phase. Scheduling then is just taking that and trying to figure out how long things will take and putting it on a calendar and getting it rolling, okay? We have a number of tools that are used for scheduling and planning. I'm going to go through those just briefly. Excel is the minimum. Like, this is the one that I expect most of you to use, is Excel. Excel breaks up easily into, days. If you want a per day type of schedule, Excel does a great job of that. You can organize it with shading. You can have hard deadlines based on a calendar. And it's just very easy to do. The most common method is a Gantt chart, which is what's shown here. So we've got, looks like, weeks and days up here. And then we've got tasks that would be listed here. And then you can even color code these. And I'm going to ask that you do some color coding for responsibility. So each team member will have a responsibility on the schedule. That doesn't mean you're doing it. That means you're responsible that it gets done. So and that should be divided up amongst teammates, right? Different responsibilities, trying to keep things on task, keep the schedule going strong. It's a living document, so it can change through time. Maybe brainstorming and design took longer than we thought it would be taking. That pushed some things back, but then we got to work overtime on those things to get those done on time, or in the end, we won't be complete. So very powerful tool, and it's used a lot. There's lots of different ways to do it. There's like flowchart that can be built. Like once something gets done, then it kicks into some other tasks, and then you can code those all out. So you'll see this kind of thing, different kinds of flowcharts. And then often you'll see something like Microsoft Scheduler, which is basically a very interactive type of spreadsheet. I mean, they act like spreadsheets. They have what's called critical paths involved, excuse me, which you should have too. But a critical path means that something must get done before something else can happen. That's a critical path. Like, you know, if you want to build a prototype, there's certain things that must be done before you get to build the prototype. So you can have multiple critical paths in a project. That's very common. And then you can have simultaneous critical paths going on. So Microsoft Project is available in the lab. I don't expect you to use it unless you know it, unless a teammate knows it. Then you could use it. That'd be super fun. But you can definitely use Excel and get a schedule built that way. It's just another example of a critical path, right? Things have to get done before something else can kick into place. All right. So after you've identified the problem in your project, one of the early things that needs to be done is brainstorming. So the reason we brainstorm is to establish a common method for a team to creatively and efficiently generate a high volume of ideas, okay? That's why we brainstorm. It should be free of criticism. So you can set boundaries like resource boundaries, and you can set realistic boundaries for your brainstorming. But other than that, we should not be critical of ideas generated. Document this. I'm going to want to see this kind of brainstorming on the project. Okay. What does it do? It encourages open thinking when a team is stuck in the same old way. So structured brainstorming and unstructured brainstorming are two different methods, and we'll talk about that. But brainstorming itself should allow team members to build on each other's creativity and just toss out a bunch of ideas. So unstructured is just going for it, right? There's just no structure, and usually the most verbal and non-introverted person on the team will have the most ideas out there, while others are potentially listening and wanting to be involved, but maybe not being involved because they're not as verbal, okay? So unstructured is not perfect. You would do the normal steps of, you know, the central question is stated, and then everyone agrees on it, and you write it down, and then ideas are given by everyone anytime. So that's unstructured. So there's other ways to do it, right? There is a structured method. And the structured method starts the same way, where you all agree upon the central question or whatever you're trying to brainstorm. This can be the big picture, or this can be a small part of it, right? Then each person in turn gives an idea. You just go around the table. If you don't have an idea, you can say pass, right? But if you have an idea, then you're going to get your shot at the table. As ideas are generated, write each one down, right? Large visible letters, like on a flow chart or a big piece of paper, so you capture that. Then you keep going until there's just everyone says pass and you run out of ideas. You can let a certain amount of time go by and then do it again if you want. That's not a bad idea. So review this written list at the end for clarity and discard any duplicates. So that is structured brainstorming. All right. Advantages, more likely to solicit ideas from everyone, even the less vocal people. Disadvantages, it's much slower. It seems to have less flow to it. So if somebody has a great idea and you want to feed on it, you can't do that because you got to wait your turn to talk, right? So there are disadvantages to structured. It's just a little less flow-like, I guess. A little less free for all, which could be good. Like it can encourage people to speak that don't really want to speak. All right. The other thing I want to talk about is need-based ideation. So ideation is the concept of coming up with ideas. And if you have a need-based ideation, then you are thinking about things as you're doing ideation, as you're brainstorming. So I would encourage needs-based ideation in your brainstorming. In the ping pong ball launcher, that could have been something like, how can I aim the ball to go in the bucket? How can the system push the ball? How can I keep it simple? How can I make it reliable? How can I make it stable? So all of these things are needs in that project. You could also add in there, I can only use cardboard. I can only use string, or I can only use these resources. So all of this is going to kind of constrain your brainstorming, which is good. It's a more effective brainstorming system. So think about need-based ideation. What are the needs what do we got to do, right? And then wrap some brainstorming around that. So the brainstorming phase after the problem statement is made is not a quick operation. It can be slow and very trying and exhausting, okay? But it's a phase that really needs to happen, and it should happen each loop. So it changes obviously in the second loop. All right, so I'm going to jump ahead a little bit. The means-based ideation is like what I have: cardboard, duct tape, adhesive, rubber bands, right? So that's also something that should be considered. All right, so here's another thing to think about. The example is designing a coffee making machine. We have to be careful with the words that we use and how we state them, and that we're all understanding the same thing. So I'm just going to go through these kind of quickly. I would like it to remind me of an English butler, like my coffee machine needs to be like an English butler, right? What's that mean? Well, the product is elegant and unassuming with clean lines. So that's potentially what it could mean. But if somebody uses terminology that you're not sure of, then you want to really get clarity. I hate it when it drips. If I pull out the pot or the filter, so that's kind of a need. And then the interpreted need would be the product keeps itself and the area around it clean. The next one, I don't like having the cord stretched all over the counter. And the flip side to that would be the product has good cord management, right? So you can kind of come up with these needs, but then you need to interpret it to a design terminology, right? I just want a good tasting cup of Joe. And on the right, it says the product makes good coffee. The product heats and keeps water at the appropriate temperature. So needs versus interpreted needs. We need to do a lot of that when we come up with a need for our project. All right, so that's pretty much it for the PowerPoint. I'm going to stop the share and introduce the project. So if I can get a new share to work, there we go. So your project, it's like I don't have it open, so I'll just go to Blackboard where it is there. Under week 4, you'll find this lecture also in here, but here it is, the BDS course challenge. So we are going to do, oh my, I hope this works. I hope you can see it. I'm actually going to stop the share and reshare just to make sure you can see it. There it is. We have a little delay going on, so I'm not being patient enough. All right, so your challenge for the term is the beverage delivery system. So that's BDS for short. The challenge is to deliver 6 12-ounce cans of frosty beverage. The frosty beverage that you are going to deliver me are going to be these wonderful gems. And you'll notice that is not a beer, that's a root beer. But it's going to be cold and frosty and delivered to me. So I'll be sitting in a lawn chair, and you will be using green materials to deliver a 6-pack and a single can. So you have to do both. It has to deliver to a table and set it down on the table. Okay. The opening is 12 feet. So you can think of it as a chasm, a ravine. I just call it an opening. It's an area that you cannot go. So 12-foot distance onto a table, set it down. 12-foot distance onto a table, set the single bottle down. Okay, that is your challenge. There are a few deliverables: team formation paper, code of ethics, problem definition, structural analysis, prototype test, and then the final challenge. So I have a calendar here for you. I have lots of information. You can start to review it. We'll talk about it in lab and we will get started. So super fun. The carrying container for the 6-pack is standard carrying container, and I will try to get that soon so you can see it. I already have the beverages, so you'll be able to see those. Here's the distribution of points for the project. So there's 100 total percentage points. The reports that you submit are 30%. The prototype is 10%. The weight performance is 30%. So weight is big, read about that. And then your final design, safety and function, that's actually doing it, is 30%. So that's the breakdown. So some of you might be worried about this. If you completely fail, is that 0 out of 30%? No, it's if you show up without a system that has any thought to it, that you would lose the 30%. So if you show up with a system you've been working on all term and it doesn't perform well, then you're still going to get most of those 30 percentage points. So there will be a rubric that you will get prior to the final design. All right. This is a draft, so I can still tweak it, especially those final percentages. And I might, based on my experience with this kind of a project. So start to read the instructions. You'll be given your teams tomorrow in lab and you'll get started. So super excited. All right, see you all tomorrow. Enjoy the weather. It is quite beautiful outside. So I'm getting a lot of natural light into my office, which is a little distracting. So, all right, take care.